Okay, let's work through this weighted average cost of capital problem. Now you see the problem in front of you. It says, suppose Alcatel-Lucent has an equity cost of capital of 12%, market capitalization of $12.06 billion, and an enterprise value of $18 billion with a debt cost of capital of 8%, and its marginal tax rate is 40%. Question A asks, what is Alcatel-Lucent's weighted average cost of capital? Now, to solve this one, they've given you quite a bit of the information for you. So all you have to do is use this formula that you see, the weighted average cost of capital, where we weight the debt cost to the equity cost. So they've given us the 12% cost of equity cost of capital, and the debt was 12.06 over a total 18, right? Enterprise value was 18 billion. And then we have to add to that the enterprise less the equity cost, whatever that comes out to be, divided by the enterprise value, and multiply that times 1 minus the tax rate. So we compute the weighted average cost of capital. And of course, I'd recommend you use Excel to do this. Now, the illustration here just shows you the math, but it's just basic math, and Excel can do that for you. So Lucent's weighted average cost of capital is 9.62%. All right, let's look at B now. B says, if Alcatel-Lucent maintains a constant debt-equity ratio, what's the value of the project with an average risk and the following expected free cash flows? And to the left of my mouse, you can see the cash flows. Okay, so we have negative 100, then positive 60, then 110, and 80. Okay, so let's take a look at that now. Okay, so on part B, given that they've given us the cash flows, we need, and there's a constant debt equity ratio and average risk, you compute the value, including the tax shield, simply by discounting the free cash flow using the weighted average cost of capital. So if you wanted to do it mathematically, you would do it as it's provided here, right? So then you'd plug in the numbers and you can come up with it. Now, I'd recommend you do this with the net present value function. I think that's the easiest way, and I've done that here. Okay, so what I did is I put the future cash flows, which are 60, 110, and 80. We know the rate is 9.62% because we've already calculated it. And then I would just compute NPV. Now, I've done it here. I'll do it again for you. You would say equal NPV, hit the left parentheses. You can call it up if you prefer to do it this way. And then tell it where the rate is. And then tell it where the cash flows are. And for cash flows 1 to 3, we're only interested in the future cash flows, we're done. And we come up with 207. And if I were to format that, it's actually 207.01, just like what's provided there. Okay, let's see if I can format this now with a $sign maybe. Okay, there you go. Maybe it makes sense to format all of these with $signs as well, so you can see what we have. All right, so let's slide down and take a look at the next part of this problem. All right, now we have part C. Okay, now I slid up just for a moment so you can see what Part C was asking. Part C said, if Alcatel-Lucent maintains its debt-equity ratio, what is the debt capacity of the project in Part B? Okay, so we're going to just continue to work this. All right, so we need to use the debt-to-equity ratio, which is simply just debt divided by equity plus debt. They've given us the information. So debt would be the full enterprise value less the equity, right? I mean, we have equity and debt. If we know the equity and the total, then we can calculate the debt. And we divide it by the total. So it's 0.33. That's our debt to value ratio. And by the way, this is just a repeat. You could probably put this just like that. Okay, and then what do we have? The project's debt capacity would be equal to that debt to value ratio times the levered value of the remaining cash flows. Now, this part, the 207.01 was the net present value of the future cash flows. Okay? So, what are we doing here? Okay, so what we're doing is multiplying the 207.01 times the 0.33. That's how we come up with 68.31. Okay, and I'll work that for you right here. I entered equal 207.01 times 33. Right? If I hit enter, you see I equal to 68.31. Now, you may wonder, well, where does the 166.92 come from? Well, that's the present value of the remaining cash flows. And the easiest way to solve that is we've already solved it here. Just eliminate the future cash flow, and it will give you the proper net present value going forward. So there's 167. And again, if I were to format that correctly, make this a little bit wide enough so you can see it, that's the 166.92. Okay, so we then multiply 166.92 times 0.33. Now we could do that over here, times 0.33, and we're going to get the 5508. Okay, now actually I probably want to change this to 166.92 because I'm going to change the formula. Okay, and to do the third one, we eliminate the second cash flow, so we've got the present value of 80 to be received 3 periods from now. That becomes 72.98, and then I can multiply the 72.98 times the 0.33 again. Okay, and that's how I come up with this calculation. Okay, and for period 3, of course, there's no remaining cash flow at all. So we're going to have 0 times 0. I'm going to undo that because I'm pulling from here. But if I were to remove the 80 here, you see that the NPV goes to 0, and that's why in the last period we have 0 times 0.33, and we get 0. Now I want to put that remaining one back there for you so you can see where it is. Okay, so this one's just going to be 0. And that's how we solve this weighted average cost of capital problem.